This is my Lab 4 presentation. The purpose of this lab was to study circuits and understand how batteries, resistors, and capacitors affect electric current. The main models and principles used were Kirchhoff's loop rule, current conversion, node rule, Ohm's law, and the results were that the electric current for the first experiment was 0.02 amps. Capacitors charge and discharge in the same amount of time, and the RC value was 0.597. The system for this lab is the circuit. The surroundings are the earth and everything around the circuit. Some potential errors were that the stopwatch measurements were not precise and that the resistors and capacitors did not function correctly. Some assumptions made were that the wires did not provide any resistance and all ammeters, voltmeters, capacitors, and resistors were ideal. One of the main observations from this experiment was that adding the ammeter parallel to the resistor increased the electric current from 0.02 amps to 0.06 amps. And when a voltmeter replaced an ammeter, the voltage read 3 volts, but there was no current. The calculated resistance for the 47 ohm resistor was 48. For the 100 ohm resistor, it was 102. For the wire and ammeter, it was found that there was 0. This is the round-trip potential plot. The delta VBA was equal to 3 volts. The delta VDC was equal to negative 0.96 volts. The delta VFE was equal to negative 2.04 volts. And the rest of the sections had changes in potential equal to 0. And there was potential difference changes across each resistor, but nowhere else. These are the charge and discharge times for the capacitor. Whenever a 10 ohm light bulb was used, it was 15.23 seconds to charge and 15.27 seconds to discharge. When a 20 ohm light bulb was used, it was 27.67 seconds to charge and 27.48 seconds to discharge. So for the same ohm light bulb, the charge and discharge times were pretty much the same. This is a plot for the RC calculations. The slope of the graph is negative 0.1674, and the RC value is found to be 5.97. One question for this lab is, what if you were doing this lab in real life and used an actual ammeter instead of an ideal simulated ammeter? What's different about a real ammeter, and how would it have affected the circuits you hooked it up to? So the ammeter would probably cause a small amount of resistance, and this would result in the current being less than what was read in the online simulation. Another question asked was, what if you were doing this lab in real life and used a real battery to charge a real capacitor with no resistor in the circuit? How quickly would our ideal model predict the capacitor to reach full charge? Would this prediction happen in real life? Explain. So the ideal model would predict that the capacitor charges very quickly, within a few seconds, and in real life, it would be slower because of a potential amount of resistance in the wires.